ladies and gentlemen, in this video we are going to start section 2.3 from page 66 to page 74 about counting techniques. According to your study guides, we are basically going to look at what are some counting techniques. For example, we are going to define sum principle, product principle, permutation, combination, factorial, and also we are going to learn how we can calculate probabilities using counting techniques. Here is your homework. You can also go and have a look at examples 2.17 and 2.23. Sorry, 2.17 to 2.23 in section 2.3, and these are two additional exercises. You can go and try, as well as exercises 32, 34, 36, and 44. When the various outcomes of an experiment are equally likely, it means the same probability is assigned to each simple event, then the task of computing probabilities reduces to counting. In particular, if NS is the number of outcomes in a sample space and NA is the number of outcomes contained in an event A, then the probability of event A is the relative frequency of event A. It means NA over NS, the number of outcomes in A, the number of outcomes in S. Look at this example. A box contains 4 blue balls, 5 red balls, and 6 green balls. If we select one ball in random, what is the probability of observing a red ball, B, a blue ball, and C, a red or green ball? You can see that in box, in total, we have 15 balls. It's the number of outcomes in sample space. So, for A, part A, the probability of observing or picking a red ball. So, if event A is picking a red ball, then the probability of A is the number of outcomes in A over the number of outcomes in S. We know that in total we have 15 balls, and also we have 5 red balls in the box. This one is A and B. A blue ball. We have 4 blue balls in this box. So B picking a blue ball. So the probability of B is NB NS. It's 450. And C, a red or green ball. Again, or green. Okay, you know that the red and green are disjoint events. They don't have anything in common. So according to axiom 3, the probability of C is the probability of red plus probability of green. So it's 515 plus 615 is 1115. You know that all of, if it's the box, we have, for example, 3 regions: red, blue, and green. So red and green are disjoint. Okay, if a list of the outcomes is available, same as the previous example, the list of the outcomes was available for us in this example. We have the list. So if a list of the outcomes is available or easy to construct, for example, is for rolling a dice, for throwing a coin, it's easy to construct. And NS, it means the number of outcomes in sample space is small. Then the numerator and denominator can be obtained easily. But if NS, it means the number of outcomes in a sample space is quite large or large, then constructing a list is not easy, it's hard, or maybe it's impossible. So in this case, by using some general counting principles or rules or formulas, it's possible to compute probabilities from this formula without a listing of outcomes. So by using these counting techniques, we can obtain the number of outcomes in A and the number of outcomes in S without listing them. Now we are going to start with counting principles. There are two counting principles. Number 1, sum or addition principle. If there are p ways to do task A and q ways to do task B, then there are p plus q ways to do A or B, to do one, not both. Please look at these keywords. And number 2, if a product or a multiplication principle, if there are p ways to do task A and q ways to do task B, then there are p times p ways to do A and B, to do both things. Okay, if we are going to do A or B, there are P plus Q ways. If we are going to do A and B, there are P times Q ways. Please note that the sum and product principle can be extended for more than 2 tasks, for example, K-task. Okay, we are going to rewrite them for 3 tasks, for example. If there are P ways to do task A and Q ways to do task B and H ways to do task C, then there are P plus Q plus H ways to do A or B or C. It means to do one of them, not all. And for this one, the product principle, if there are P ways to do task A and Q ways to do task B and H ways to do task C, then there are P times Q times H ways to do A and B and C. It means to do all of them. Okay? Now look at this example. Assume the shop has only 3 chocolate bars and 2 packets of chips. Every item is distinct. Question 1. How many ways can we pick one snack from the shop? So it's a time to make decision. At this moment, I want a bar of chocolate or a packet of chips. Or. So there are 3 ways to choose one chocolate and 2 ways to choose one chips. So in total 3 plus 2, it means 5 ways. There are 5 ways to choose one snack. And question 2. How many ways can we pick one chocolate and one packet of chips? Here in question 1, you have to pick one of them, not both. But here, look at how many ways can we pick one chocolate and one packet of chips. So we should use product principle. There is 3 ways for picking a chocolate and 2 ways for picking a chips. So 3 times 2, there are 6 ways to pick one chocolate and one packet of chips. You can see this keyword here. And now look at this diagram. The first choice and the second choice. For chocolate, there are 3 outcomes for chocolate. Chocolate 1, chocolate 2, chocolate 3. In front of each of them, you should write the outcomes for chips. For chips, we have chips 1, chips 2. Again, for chocolate 2, chips 1, chips 2. And for chocolate 3, chips 1, chips 2. So we can pick chocolate 1 with chips 1, chocolate 1 with chips 2, chocolate 2 with chips 1, chocolate 2 with chips 2, chocolate 3 with chips 1, and chocolate 3 with chips 2. So in total there are 6 ways to pick one chocolate and one chips. And look at this example. How many circles you can see in this picture? Okay, we can go and count them. But the second way is using the product principle. In this picture, we can see we have 6 columns and 4 rows. Look at here, 6 columns and 4 rows. So 6 times 4, we have 24 circles in this picture.